There we are.
Hello everybody, welcome back to Monday Mythbusters. Sorry we missed last week, but we're back stronger than ever, ready to go. Leslie Harrington here, awesome health coach extraordinaire, transformational health coach, and myself, Dr. Carolyn George. So welcome back everybody. I hope you've come with lots of good questions about water. It's the nectar of life, right?
Super great topic tonight, guys. We've got so much to cover, and there's just so many things around water that will blow your mind. A lot of things that people probably aren't really considerate of or aware of.
Yes, so first we wanted to talk about what's important about water. Why is water even an issue for anybody? Well, because water is life, right? We started in the water, and we need water. We need to be bathed in water. It maintains our DNA. It helps to prevent constipation. It helps to, all the metabolic processes require water, so anything that you're going to do from thinking to exercise is going to need some water, and it also helps to regulate your body temperature. I've got a whole little list here. Your cerebral spinal fluid and your spinal canal and around your brain is in large part water, which is one of the reasons that people will get headaches when they don't drink enough water. So it comes in from many different areas. It's really important for our little mitochondria, their little energy engines in our cells, and so that's another good reason to eat it, drink it. And it is 90% of water transports oxygen, nutrients, lymph, and fluid. So it really helps our body to clear of all the cellular waste products. So water is really key for many different things.
Brian and Blair are on. Hi guys, thank you for joining us. Anybody else is on, say hi, give us a little shout out here.
Ellen and Marianne, hi there.
Oh, I missed that.
Yeah.
Nice guys.
So water is important. It is the most important thing. We can live for quite a while without food, but we cannot live for very long without water. So it really behooves us to make sure that we have a lot of water, all that we need, and to make sure that it's clean, and thus our topic tonight. So some of the things that we worry about in water can be anything from infectious agents like viruses, bacteria, parasites, but also chemicals. So a lot of the water table right now has, in fact, all of the water table has different chemicals in it, and even though DEET was outlawed years ago, we still find it in the water in the North Atlantic or Arctic, and so these chemicals are pervasive. They often don't break down very well, and so they stay in our water table. And you're going to come to find out why we are still drinking them and what our water services, our water agencies do to try to remove it, but they still don't get it all.
Yeah, and I think it's important to understand what is truly going on when it comes to the cleanliness of our water and what the responsibility is and what they're really looking to pull out of it. And one of the things that I think everyone would find interesting is that you have access to a report for your city or your town of your municipal water. And as you can see here, there's tables here that show you the different levels of different types of nitrates, arsenic, different types of chemicals, and the leads and different things like that in your water supply right here in your own town. So, and this will change, and they do it for every year. They'll run a new report, but it gives you a little bit of information of how well your area is able to kind of do what they are attempting to do, which is give us the best water supply that we can. We're just not cut out to be, we're not equipped for all of the things that are kind of invading our water supply.
And so where did you get that particular report from?
This one was for the city of Davie, which is where I live. So the town of Davie, you go into water municipality report, quality water report, and I mean they have them right in there. They're not unusual to be accessed.
I think it's actually required.
To have it posted.
To have that, yeah.
Okay.
And if you want an easy place to kind of find those things, if you go to the Environmental Working Group, ewg.org, they have all of this together. They have a great whole session, a whole area on water, and so a lot of what we're going to talk about tonight you can get through the ewg.org, but there's also different counties will have their own data that might be more up to date than what EWG has, because when I looked at their stuff, they were looking at 2015.
Okay. Yeah,
so
it'll be
I think
more.
you've got 2016, 2017
Yeah, they're about
data.
a year behind, but they're at least still.
Yeah, and 2017 data probably still not all in. But the more we ask these municipalities and areas, the more we talk to our legislators about really looking at this and making it a priority, the more information we'll get, because there's a lot of stuff that they actually test for that they're not required to put up on their websites, and so they don't. So so we need to be very verbal, as in most things. We need to really take ownership and ask for what we want to know, what we're eating, what we're drinking, etc. So one of the things that we wanted to kind of touch base on is, I know everybody wants to know what's the best source of water to get. Okay, so number one, there is no best source. Okay, everything has got a pro and a con to it. And that might be cost of it, that might be contaminants that are left in, or the fact that everything's taken out. So we'll kind of touch on some of the key technologies that are out there and what are the pros and cons of those. Okay?
Yeah, so there's no perfect water. There are going to be lesser of evils. There's going to be ways that you can break it down that's the most either affordable or attainable for you. And it's going to be, preparing is going to come into play, just like when we talk about food prep, when you're going on airplanes, when you're going to concerts, when you're going out and you're driving around and you're in a place where you just don't have access to water a lot. Do you have those stainless steel bottles? Do you have glass bottles, things like that you can fill it with the quality water that you have, your source that you have? Bearing in mind that we're going to get into bottled water and what does that really mean and how great is bottled water for you. I know there's been a lot of news out there about Aquafina and Pepsi and how they're really technically bottled water is in fact tap water. So one of our topics is, moving on to, is bottled water really better? And bottled water does not equal safe or clean water. So if anything, it could be even more dangerous because of the BPAs involved in the actual packaging of the water.
It can be worse on many levels. So there's the BPA that we have to deal with. There's the fact that it's not often any better than tap water. Some companies can be, but you would have to test them. And they are not required to test any of their water. Your local municipality is required to test the water. These bottling companies are not. So you really don't know what you get unless you have a third party go in. So water quality is an issue. The BPA contaminant is an issue. And then you think about, what do we do with all of those water bottles afterwards, right? And so they're filling up landfills. We now have a little mini continent the size of Texas that's out in the Pacific that is all just our plastics and our junk that have we've sent out to sea and is sitting there, and it's the size of Texas. That's our garbage. And a lot of that is plastic bottles. So this is a huge issue because we're not going to have clean water. We're not going to have a clean earth if we keep on just dropping our stuff all over the place. And that plastic is not biodegradable. Surprise, surprise, right? So it's a real big issue for this little earth that we have to make work for all of the millions and billions of us over time. So if we keep doing this, I think you gave me a statistic, in the next 30 years, there's going to be, what was it? Was that a statistic you gave me on the water?
Oh,
on the water bottles? Anyway,
bottles.
some massive amount of water bottles that we're going to have, that we're going to be using every year in the next few years, unless we really make a big effort to curtail the plastic.
Yeah, that's disturbing.
Yeah.
It's just
And then you think about, where does the plastic come from? It's coming from petroleum products, right? So we need to get more oil and harvest more of those petroleum products
to put towards
that,
yeah,
right?
plastic.
So it doesn't make sense on many different levels. So I really encourage people to find alternatives to those plastic bottles, and they're everywhere. They abound. There's, like she said, there's glass. There's Tevana has them, Whole Foods has them. There's different metal bottles, but there's a lot of different really good quality.
Ways to transport safely,
right.
And then it's a matter of what you're putting in there, and that's what we're talking about tonight. Is really what are you putting in there?
Right.
And a couple of the fun facts on water is that so many people are dehydrated. Over 75% of Americans are dehydrated. And 5% or mild dehydration can slow down your metabolism significantly. So 3% in a body in metabolism, that's actually a significant impact. So bearing in mind that it's something that's critical for our survival, it's something that's important when it comes up with any condition, any type of condition you're dealing with. Quality water is always going to be one of the priority things that we talk about, and how much you're getting in your body. Critical for every function. So
right, and lack of it, like we mentioned before, constipation, headaches. Actually, a lot of people will experience what they think is hunger pain, but it's really that you're thirsty. So it affects really everything. And if you're really wanting to prevent kidney stones, you want to stay well hydrated. There's a lot of areas of your health that staying hydrated can be really pivotal.
Yes,
so
absolutely.
Drink lots of water. So how much water, right? That's the next question, and then we're going to go into some of the technology, but wanted to give you a few little pointers first. So in general, you're looking for at least 64 ounces a day. If you're more than 100 pounds, you probably need more than that. If you want a little equation, people always like equations. If you take your body weight in pounds and multiply it by 2/3, that's how many ounces you should have. So if you're 140 pounds, you want about 94 ounces. And if you're going to work out, for each 30 minutes of exercise, you want to take on an extra 12 ounces. So you really want to make sure when you're exercising that you're really well hydrated, so you don't get lightheaded, you don't pass out. That's not fun. But it will also help your muscles. It'll help you to build those new muscles better, and help you to get rid of the lactic acid that you produce when you are exercising.
Yeah, and I think it's important to note too some of the electrolytes and some of the minerals that are critical for water too. So some people, I know we have this kind of anti-sodium and things like that, but having that sodium, potassium, you don't want to go out and grab a Gatorade per se, but when you're drinking a lot of this water, you need to make sure that you have the proper minerals as well. So having a little bit of Himalayan sea salt, even if it's a sprinkle, either in your water, or it can be, on your food or something like that, but just making sure that you have minerals to kind of hold it in, so some people are drinking, but they just have no minerals. So it's kind of running right through them.
Especially if you're a big sweater. If you sweat a lot, if you're outside, if you're working outside, or you're exposed to a lot of the humidity like we have down here in Florida, you can sweat lots of those minerals, and that can really, really disturb your whole balance. And the body's pretty good at maintaining homeostasis. I bungled over that word. But if you're in those extremes, it doesn't have the reserve. So you need to be eating. And then down here, what we'll see a lot of, especially people that work outside, is they'll drink coconut water, because there's a lot of minerals in that. And that can be, down here, it's going to be right from the coconuts, right? We don't have to get it bottled.
Yeah, a lot of people ask me if the type of water, like does juices count? Do soup and teas and coffee and things like that? And from an ounces wise, yes, having those liquids is important. If you're drinking something like coffee that's somewhat dehydrating, you want to make sure you're offsetting that. So I wouldn't necessarily consider coffee as like your sole source of your fluids.
No, that's definitely
that one would be nixed. But your hot teas and the herbal teas and things like that are decaffeinated, those would count, and even some broths and things like that would be okay. But and again, those are going to have sodium. I wanted to go back a little bit to the quality of water, and what you won't see in this report from the city is going to be, you're not going to see some of the chemicals that you would be surprised to find are actually in our water. So this is going to be whatever they can do to kill the bacteria. They're going to be making it safe, in theory, for you to be able to drink without getting some sort of infections, right? And what they're not really able to account for is pharmaceutical drugs. Hormones, anything that someone can take orally as a medication, and prescriptions and things like that. So basically drugs. There's quite a few number of drugs that they're finding in the water supplies.
Right.
And it's a significant problem, and it's partly due to the disposal and partly just due from the excretion. Right. So most of what we take orally is really not absorbed. It's a percentage of it that's absorbed, and then the rest goes out processed.
And even those that are absorbed, we're going to metabolize, but we'll take those metabolites, which still often have some effect.
Yes.
So a lot of hormones will still have effect, and other medications, blood pressure medications, heart medications. They're finding those things also in the Arctic. So anything that we're ingesting, or like you say, any pharmaceuticals, we might pour the pills out in the toilet, and then boom, you get a blast of that.
Yeah.
And your municipal water companies are not required to remove that. That's not, in their mandate is looking for infectious agents by and large, and so they're not really worried about these potentially carcinogenic or other types of chemicals that can affect our hormones in the water supply. And so you might say, well, that they're very small, they're diluted because there's billions of liters of water there. And that's true, and so that works in our benefit. But when you think about it, the hormones in our body are in parts per billion as well. So small amounts of things can still exert an effect.
I always make a joke with my brother-in-law. I tell him, because he drinks a lot of bottled water, that, you know, he's going to get man boobs from all the estrogens and the BPA, and then, you know, and what could be in the water as well.
Right.
So just something to be aware of. You know, there's not a huge amount you can do about it other than pay attention to some of the things that we're talking about, and then when we look into the other types of technology that's going to help you clean up some of that.
Right. So other things that you might find in your tap water are fracking agents. They are not required to be removed unless they reach a certain level. And the government in each municipality or each state will set limits on what they think is allowable, and they can change those limits. They've changed the limits here in Florida about a year or so ago. They increased the amount that was tolerable, and I've got my own ideas about why they might do that, but just to say that they are, these are numbers that are flexible, they're fluid, and so it's good to at least be aware that there's all kinds of chemicals in our water that are not just the pharmaceuticals, not just the hormones, not just infectious agents, but other things that we use in our environment, from gasoline. There's, for example, MTBE, which used to be unleaded gas, which has been out of use now for decades, but still the MTBE is in the water table and can be soaked up by plants when they're growing, and so we can get them. They can be in a water supply, especially if it's well water, and they have effects as well. So these are all things that we don't need to freak out about, but I think it's just good to be aware that we're not just getting H2O when we're drinking our water.
Yeah. And to kind of go along with that idea, just to kind of make this even wider of a topic, is, you know, when you're in the shower, you're washing things off of your skin, which, you know, going into a whole nother topic that we'll get into at some point would be skincare and some of the more safe chemicals to put on our bodies, or non-chemicals. You know, that is also falling into the water supply as well. So when we're talking about filters and things like that, just bear in mind that we're also talking about your skin. So your skin's your largest organ, and having filters within your shower heads and things like that are also going to protect you from some of these contaminants getting into your body through, you know, topically through the skin.
And the skin is a great way to give medications. We give testosterone, estrogen, a lot of other medications through our skin, painkillers, etc. So we tend to think, oh, water is just running off of us and it's not going to absorb, but it does absorb through our skin, there's no question. Also, though, you have to think, when you're having the shower spray, that aerosolizes the water, and so you inhale then, and that brings it into your body in a different way. So we have a lot of different ways of absorbing the things that are in water, not just through drinking it.
It's so fascinating.
Yeah, so what do we do? That's always
yeah,
the question,
right?
right?
Okay, we're done with the doomsday.
Yeah.
We're ready for like the fun stuff.
So there's all kinds of stuff in our water that we probably don't want. And there's a lot of things we do want. We didn't, I think you mentioned it, but there's all the minerals. We want the calcium and the magnesium and other minerals that are in there. They can be really good for us. So that hard water, although not great for our taps, so it's also good for us to drink. So we can get good amounts there. So we're going to go through some of the technology, some of the different kinds of water filters that are out there. And like I said at the very beginning, there is no perfect water filter. Everything's got a pro or a con. So we're going to give you some of them, and I invite you to go onto that environmentalworkinggroup.org website, and they will kind of fill it out, and you can plunk in what your particular contaminant is that you're worried about. And you can know what you should be worried about by checking out what's in your water supply in your local county. So there's a few steps. First, check out what's in your local water supply that's mentioned by the municipal water supply people. And then you can also go and look at the Environmental Working Group, and they've done some tests to look at some of the other contaminants. And there's other companies that will do that, not-for-profit groups that will look at other contaminants. And then you can plug it into the different filter types and see, okay, if I want to get rid of lead, what kind of filter should I use? If I want to get rid of trimethyl benzene, what kind of filter do I want to use? So you can try to look for those different chemicals specific to you,
to your area,
right? Because everybody's going to have different needs. If you're in Flint, Michigan, you want to get rid of the lead, right? That's kind of what started everybody thinking about this, but it's more than just lead.
Yeah. So some of the technologies, actually one of the most people would be familiar with something like a Brita filter, right? It used to be like a countertop. You put them in your fridge, and that's actually, to me, would be kind of your first step, right? If you're going to do nothing, get yourself a Brita filter, and that's going to at least get some of the bacteria, clean up the water a little bit. It's the chlorine and...
It's a carbon filter.
Okay.
Yeah, so it's an activated carbon, and it kind of binds to a lot of these things and pulls them out. So things that you smell generally are going to be pulled out with the carbon filters. So that's like a chlorine or that type of thing. And you have to have the water flowing through it. So that's one of the problems with Britas, or anything that uses that activated charcoal that's in a pitcher, for example. When you're pouring it, if you pour and it goes around the filter, or the filter's not in properly and it goes around it, then you're not going to be filtering it because it's gone around it, not through it. So you have to make sure that you're using those types of filters appropriately.
Yeah. And then cleaning and replacing too. I think that's a big thing. A lot of people tend to
put it
watch
in once and a year
light
later
on your refrigerator scream at you for 6 months before you go and get the new filter.
And that's the other place where you'll often see those carbon filters is on your refrigerator.
Okay.
Yeah. So carbon filters are very good. They do a lot of good removal of different contaminants, but they're not going to remove everything.
Yeah.
And so only certain sizes will be held up by that, and they have to have a certain kind of ionic signature, I guess. I'm not a water technologist, so I don't know all the details, but I do know that you can get some of them that can remove asbestos and lead and mercury and the volatile organic compounds, but it doesn't remove arsenic, fluoride, hexavalent chromium. If you're worried about that, that is not a common one, but nitrate or perchlorate, and perchlorate comes from our gasoline and fossil fuels.
Yeah, and if you're wondering too, like some of this stuff, how does it get in our water, right? It's really from runoff from nearby plants and different things and even like GMOs and pesticides and things like that. Those are all things that we have exposure to just from the spray and the overspray. So the things that we're concerned about with our food is similar in this case. Exactly.
So then there's also some ceramic filters, and these have little tiny holes in them that are kind of similar to the carbon, but they block solid contaminant such as cysts from parasites and certain sediments. But they don't remove any chemical contaminants. So you might have a ceramic filter on the bottom of your tap. Often people will screw one into where your water comes out.
Actual filter.
So you can get those. Then there's a whole big group of deionizing filters. So they use an ion exchange process that removes mineral salts and other electrically charged molecules or ions. But it doesn't remove microorganisms or the non-ionic contaminants like the trihalomethanes and other VOCs, those volatile organic compounds. So that is useful, and some people really love their ionic filter, and that might have some benefits. From the research I've done, I really don't think that they have shown that they have significant benefit, but they can alkalize the water, and that can have benefit. So you can alkalize or make more alkaline your water, and you can ionize it, and those are two separate things, but something like a Kangen water filter would do both. And I think there's mounting evidence that more alkaline water can be beneficial. There's some studies that show that it can improve your blood sugar, decrease your cholesterol, and pretty amazing stuff. But we haven't done any big human studies with that, so that needs to be done, replicated, the animal studies. And the ionizing part of it, I haven't seen any really convincing studies that show that makes a big difference. So I don't think it's going to hurt you if you've got that. That's fine, but know that it's still not taking out the microorganisms or anything that's not ionic.
Yeah, and then on the same side with the alkaline water, so that's like you said, it's a separate process. That's not really a filtering process per se. right? It's more of something you add to the water to make it kind of not like a softer, but what it was it sodium
Right, so it
bicarbonate?
changes the pH. So you can
Okay.
add in just like a teaspoon, I think it's approximately a liter, 1 teaspoon per liter of water of sodium bicarb, just buy it at the store, and that will alkalize your water. And there are some studies that show that that's beneficial. Most of our water we'll get, especially the ones in bottles, will be between 7 and 7.5 pH. And so when they're alkalizing it to 8.5, 9, that type of thing.
Yeah. So, I think I know you have a couple more here.
Yeah.
Under the,
So mechanical filters, so they're like the ceramic filters, but they block. They're used in conjunction often with other technologies, and they still don't remove the chemical contaminants. Then there's ozone, which can kill bacteria and other organisms in your water, but it's not effective again at removing the chemicals, all these other things that we've talked about. Then you've got UV radiation, which is great at killing bacteria and a lot of other organisms, but again, does not remove chemical contaminants. You've got water softeners that use that ion exchange process, and they can help, but they don't remove most of the contaminants. And the water softeners usually replace calcium and magnesium with sodium. So if sodium is an issue for you, if you've got, excuse me, heart failure or something like that, then you don't want to have high sodium. You want that calcium and magnesium.
So in general, if you're looking at from a filter standpoint, so some of these, like she was just describing at the end there, are things we're not necessarily as concerned about because our municipal water supply does capture some of these things, the bacteria, the parasites, things like that. So when you're looking to kind of enhance what you're already getting from your city, you're looking for the filter that's going to kind of clean out more stuff, right? The alkalizing is a separate process. The one we did not mention was the reverse osmosis.
Save the best for last.
Save the best for last. So if we had to kind of narrow all of it down and say the one thing that would probably be the most beneficial would be a reverse osmosis system, which actually does kind of gets everything. And the disadvantage to that is it takes away some of the water, the foundation of the water, which has the minerals and the things that you want to have. So you want to have that like real quality water. There are ways of putting in those minerals, putting them back in,
or getting them in your foods elsewhere.
Yeah.
And one of the other negatives of reverse osmosis is that it requires a lot of water. So for every liter of reverse osmosis water you get, you waste about 3 other liters. So it's very water wasting, and it's also highly energy demanding. So it's a very energetic, requiring process, and so it's definitely not perfect. I think we can come up with something better. Maybe we've got some college students out there that are working on it right now, but for what we've got right now, reverse osmosis, if you're not looking at cost, if you're not looking at the waste of the water and the high energy requirement, that's going to be your best to get rid of the chemicals and the microorganisms and keep you safe from all of those types of things.
Yeah, reverse osmosis, I have a little countertop one that, to your point, when you fill the tank in the back, this is the one, if you guys have seen on Facebook and stuff, there's an advertisement where they pour soda in the back of the filter and it comes out white and clear, in the filter itself. It's actually a great system for countertop. You can put it in the fridge or not, but to your point, I fill this huge tank and it ends up with about that much water left in it, plus whatever it filters out into the smaller compartment. So there is a lot of wastewater there that doesn't go through. And then also you can do reverse osmosis through your plumbing system. So you can actually have it installed and have it run through your home. And
it sounds expensive, and of course it is a bit, but when you think about all the bottled water that people are using because they think that it's healthier than their tap water, if you spend $1,000 on putting in a reverse osmosis system into your home, then it's going to your different taps, and you actually are going to save money pretty quickly if you're not getting that bottled water and you just got a few containers that you use, wherever you go. So you can do it to the whole house, you can do it just to the kitchen, or you can do, like Leslie has, you can have the contraption that goes just right on your sink or on the countertop.
Yeah, the countertop, I think it's just for a family. It's a little bit on the small side. For me, I keep it for like coffees and things like that. One of my favorite, I have a water delivery system. It's a Mountain Valley spring water, and they deliver huge glass bottles, and I have a dispenser. And then I get some smaller bottles that I can continually refill. So that for me is kind of my saving day, what I run around with.
Yeah. Now, just as a side point though, that Mountain Valley spring water is going to have all the beautiful minerals, and it's filtered through the earth, which is very cool. But because we know all those chemicals are in the Arctic and in our water everywhere, she's also going to be getting some of those chemicals.
No perfect water.
No perfect water. So if she took that and then put it through a carbon filter, she would get rid of some of those things.
And then I can put it through my reverse osmosis on the countertop.
Or your reverse osmosis on the countertop, yeah. But then she's getting rid of all the good minerals that she wants.
And then my bottle's only half full.
All right, yeah. So again, you have to work with where you live. If you live in the Keys and you have access to certain things, and maybe you've got more issues with heavy metals and minerals and stuff like that, then you're going to want one thing. If you're working in some place like Flint where you've got lead, is a big issue, then you're looking for others. So you really need to personalize it and see what's best for your particular situation.
And I think it's like when you know better, you do better. There's, the lesser of the evils. If you stagger it out and you have the access and the resources to do something simple, go for that Brita filter. And then if you're in a place where you're kind of gradually starting to learn some of this stuff, it's an evolution. Learning all these little tidbits that we're sharing each week is something that if you tried to do all this overnight, it would be overwhelming and you'd throw in the towel.
Right.
So, nothing to freak out. It is what it is. It's what we're here and we're exposed to. But just so you know,